Okay, so I got a new pen and a new tablet, so things might be a little bit different today. Okay, here we go. So we'll do this. Not that difficult. I have a new pen, so that makes a whole world of difference to me. All right, so first one, you got to understand what this says. This is a division problem, right? It's this the difference of these two numbers divided by the bottom. So if you wanted to, you can change and maybe if you wanted to, and write it like this. It means the same thing. I'm putting the bottom in parentheses because it's negative. Okay, but this and this, the top and this expression in blue, they say the same thing. So in order, before you divide, obviously you gotta do the parentheses here and find what the difference is, and then you can divide. So let's do that. Well, you notice that we have to find the common denominator. The common denominator is 16. That's already a 16, so that doesn't change. And then 1/4, well, it's times 4, so therefore the top times 4. So that's what I'm going to have. So again, let me keep this in parentheses and just copy the rest step by step. This is nice and easy, right? So 9 minus 4 is just going to be 5 over 16. Let me just throw that over here. 5 over 16, and then divide that by negative 10 over 8. Well, we're going to multiply by the reciprocal, 5 over 16 times, I'm going to do 8 over 10, negative, and that's it. And then can we simplify anything? Can we take one of the two numerators and simplify with one of the two denominators? I think we can. We can do the 5 and the 10, right? 5 divided by 5 is 1. 10 divided by 5 is 2. I can do the 8 and 16. I can divide the 8 by 1. I'm sorry, divide the 8 by 8. And 16 I can divide by 8 and gives me 2. Look how much simpler this becomes. Well, it's a positive divided times a negative, so that's a negative. 1 times 1 on top is 1. And 2 times 2 at the bottom is 4. That's my answer for that first question. So this one, well, it's a little bit more work, but nevertheless, it's still the same idea. So again, I'm going to, you know what? I'm going to just pull. I'm going to do this part first, this part second, and then I'm going to divide. So let me focus on the top one. It's negative 1/4 divided by negative 3. Well, let me put this over 1, right? So I get negative 1/4 times negative 3 over 1. Sorry, I'm going to do the reciprocal 1 over 3. So a negative times a negative is a positive, so that's going to be a positive, and 1 times 1 is 1, and at the bottom 4 times 3 is 12. So that whole thing on the top, I'm going to replace it, and I'm going to write it over here with 1 over 12. Over, let me come over here, and then erase the bottom part. Now I'm going to write 5/6 minus 1/3. And again, we need to find a common denominator, which is 6. Let's change everything to 6. Well, that was already a 6, so no change is necessary, but the 3 became a 6 by times 2, so I multiply the top by 2. Well, simple subtraction. I get a 6 here, and 5 minus 2 is 3/6. So, and if you wanted to, you can simplify 3/6 and use a half. So the bottom part, this bottom part, that equals to a half. And divide that by negative a half. So that's what I have so far. So now I can do the problem much easier, right? Because I simplify the top expression, the bottom expression. So let me rewrite that. So that says a half. And then this bar over here means division, so it's divided by half. And guess what? Divided by that other negative a half. So that's what I have right now. So let's take care of these two. A half times a half is going to be half times 2 over 1, right? So keep the first fraction, change the division to multiplication, and use a reciprocal of 1 over 2, which is 2 over 1. And if you multiply this across, we can. You get 2 over 2, which is just simple 1. So this whole thing becomes 1. So I'm going to rewrite this. So again, this whole part from here to here equals 1. And then it's 1 divided by negative a half. So let's bring that part over here. 1 divided by negative a half, the same thing as 1. I'm going to put that over 1 times, and I'm going to use a reciprocal here, which is 2 over 1. If I multiply, it's a positive times a negative. It's going to give me a negative, and 1 times negative 2 is negative 2. The bottom I don't have to worry about because it's just 1 times 1. So the final answer is negative 2. So it's really not that bad, right? These are called complex fractions. It's not a big deal. Following 2 is just simple adding and subtraction, subtracting of fractions. So I like to change them to, what do you call, improper fractions, okay? So it's 7 times, I'll put up times and a plus, 7 times 6 is 42, plus 5, 47. 47 over 7 negative, plus 5 times 3 is 15, 18 over 5. We need to find a common denominator. In this case, it's going to be, hopefully adjust here, it's going to be 35 plus negative 35 plus something over 35. So how did the 7 become a 35 was times 5, so I'm going to multiply the top times 5. 5 times 7 is 35, carries 3, so that's going to give me 235. And then 5 times 7 over here, and then times 7 on top, 126. So if we add these, first of all, I know my answer is going to be negative. So first of all, it's going to be 35, something over 35. It's a negative plus a positive. Who's going to win? The negatives, because there's more negatives over here. How many more negatives? Well, let's subtract. 235 minus 126. It's going to give me 15 minus 6 is 9, 0, 109, but negative. You can change that to a mixed number, but this would have been fine right now. Okay. Likewise, the other one is the same, but I'm going to make a few changes here. Well, because one is a decimal and the other one's a fraction. I prefer to change it to a decimal. You can change it to a fraction, but I'm going to show you that I think the decimal is much easier. So the first thing I'm going to do is actually change this subtraction problem to addition problem. So I'm going to get negative 3, just write it, negative 3 and 3/5. Then I change subtraction to addition, and I'm going to change this to this additive inverse, which is 0.8. So now I change the subtraction addition. Now I'm going to change this guy over here to a decimal. 3/5 is the same thing as 0.6. So it's, instead of negative 3 and 3/5, I'm going to write negative 3.6. It's the same exact thing. And then plus 0.8. Look how much easier this is. I don't have to find denominators. I don't have to deal with mixed numbers, improper fractions, etc. It's just decimals. So who's going to win? The negatives. Why? Because there's more. So let's subtract 3.6 minus 0.8. It's going to give us borrowing here 2.8, but negative. Okay, so this is how we manipulate, write our numbers to our advantage. In this case, I changed it to decimals to make my life easier. You could have done it with fractions. I chose decimals. Express as a ratio of 2 integers. This will be on your quiz. So let's see if I have enough room there. The first thing I want to do is write this in this manner, right? And we know that 0.7 as a bar notation is a shorter version of writing this, right? Because the 7 repeats forever now. So this is a shorter notation. But I want to change this to a fraction. So how many numbers are repeating? Well, it's one number, the 7, repeating infinite times. So that's why it's 0.7. 0.7 bar notation. So, because it's one number repeating, we're going to multiply both sides by 10. So I'm going to multiply this side by 10, multiply this side by 10. Well, what's 10 times x? It's going to give me 10x. Now on the other side, I'm going to multiply. Imagine if I take 0.77777 to the infinite and multiply by 10. Remember we talked about, right? Multiplying by 10 means we shift that decimal 1 over, right? So that's going to give me 7.7777 forever and ever, which I can write that as 7.7 bar notation. And that's what I'm going to write on top here, 7.7 bar notations. Now, what I'm going to do with my two equations is I'm going to subtract them. 10x minus x is 9x. 7.7, well, the 0.7, this bar notation minus 7 bar notation, it's going to cross out, right, because it's going to be 0. And then 7 minus 0 is just 0. Divide both sides by 9. It's a one-step equation, right? This cancels out, and x equals 7 over 9. So 0.7 bar notation as a, fraction, or as a ratio of two integers is 7 over 9. Next one, 2.41. Again, let's set this, and I guess I'll write it here. X equals 2.41. That, I don't know what that was. I still don't know what it is. Here we go. So 2.41, and again, I'm going to write what that means. It's 2.41, 41, 41, etc., forever and ever. Now, what numbers are repeating? 4 1 is repeating, so that's why we write it, the bar notation, on top of the 4 1. So there's two numbers repeating. When there's two numbers repeating, I like you to multiply both sides, change colors here, by 100. I'll multiply this by 100. 100 times x, I'm going to put 100x. And on this side, if I multiply this, again, remember that little exercise we did in class, right? If I multiply a number like this, that goes on and on, times 100, it means that the decimal is going to shift over 1, 2 places. So after I multiply that by 100, it's going to give me 241.41, 41, forever and ever, which I can shorthand hit this and write as 2.41, 41 bar notation. So 2.41 times 100, bar notation here is the same thing. It's equals to 241.41 notation, right? Because decimal shifted over. Why am I doing diagonals? Okay, so 100x minus x is 99x. 241, so these two will be 0, right? And then 241 minus 2 is 239. Divide both sides by 99. And x equals, so this will simplify to 1, 239 over 99. And that's my answer to that one. To change to an equivalent decimal. So this one is just asking you to change 55 over 12 to a decimal and 8 over 15. So let's do, is there an easier one? Well, let's do 8 over 15. So remember, when we divide, the 8 goes inside, the 15 goes outside. Can 15 go into 8? No, add a 0. Add a decimal, allows me to add a 0 now, right? 15 goes into 8 5 times, which is 75. 5 left over, I'm going to bring a 0 down. 15 goes into 4 and 50 3 times, which is 45. And I have another 5 left over, so now you know what the pattern is going to be. So if I have 50 left over, again, it's going to be a 3. 15 times 3 is 45, and 5 left over. So you notice that that 3 is going to repeat itself forever and ever, so it's going to be 0.53, and the repeating number is a 3, and that's would be your equivalent, right? 55 over 12 is going to be likewise, so we're going to go like this, 55 inside, 12 outside. 12 times 55 4 times, which is 48. We're going to subtract. That's going to give us 7 left over. Let's add a decimal. Bring a 0 down. 7 goes into 76 times. No, 5 times, which is 60. 10 left over. Let's just keep going for a little bit. 12 goes into 109 8 times, which is 96. 4 left over. Let me add another 0. Just keep on going for a little bit more. And 12 goes into 40 3 times, which is 36. Here is my repeating pattern. I'm going to have 4 left over, and if I bring another 0 down, it's going to be 3 again, and etc. So it's going to be 3, 3, 3, 3 forever and ever. So the answer is going to be 4.583 bar notation, because 3 is the number that repeats forever and ever. Okay, that's just division. Multiply, divide the fractions. Okay, so again, this is just an exercise in the algorithm and the process in which you multiply or divide two fractions. It's nothing new. 4 times 2 is 8. So this is 13 over 4 times 9, negative 10 over 3. You can simplify if you can, so I can use a 4 and a 10 here, and I'm going to simplify them. So imagine 10 over 4, if I divide this by 2 and divide this by 2, I get 5 over 2. I'm going to change the 10 to 5 and the 4 to 2. Can I simplify anything else? No. So let's multiply. At the bottom is 2 times 3, which is 6, and the top is 13 times 5, which is 65. No, 15, 65. Negative, by the way. And you can change that to a, what do you call, um, mixed number, which is going to be 6, 5 over 6, but negative. Same thing here, 4/5 times, and we're going to change that mix to an improper. 7 times 3 is 21, plus 5, 26 over 7. Can I simplify anything? No, I can't actually. So the bottom is 35, and the top is going to be 24, 108, 104. That's going to give us, 372, 34 over 35. So either this or this, just fine. So it depends on the multiple choice, it depends on the instruction of the question. So it's kind of repetitive over here, but this is division actually, so sorry. We want to change this to multiplication, but before we do that, let's make sure we change it, our fractions, our mixed numbers to improper fractions. So we're going to get that this is 16 over 5 divided by 7 over 8. Now I can switch them. 16 over 5 times 8 over 7. And I can't simplify anything, so 5 times 7 at the bottom is 35, and 16 times 8 is 48, 108. Didn't I just do it? Well, and 35 goes into that 3 times, and 3 over 35. 3 times, am I doing this right? Yeah, 7105, so I'm all right. This one, it's going to be 2 times 5 is 10, plus 1 is 11 over 2, divided, sorry, negative. And then 3 times 2 is 6, plus 2 is 8, 8 over 3. Let's switch this to a multiplication problem. Right, by multiplying by the reciprocal. Can I simplify anything? No. 3 and 8 doesn't work, 3 and 2 doesn't work, 11 and 2 does not work, and 11 and 8 does not work. So, negative and negative is a positive. 11 times 3 is 33. 2 times 8 is 16. 16 goes 32 2 times, and 1 over 16. Evaluate. Ugh, yuck. Really? This is going to be... Well, it's not that bad. So here's the thing, though. I hope you're getting, I think, little hints that I'm trying to give you. So anytime you have fractions that you can change to decimals. So anything, for example, let me go over this. The fifths, the 1/5, the 2/5, 3/5, and I think I guess 4/5, the 1/4, 2/4, the 3/4, the halves. The eighth, not so much, but these at least, and the tenths, anything that's over 10. 2 over 10, 3 over 10, I mean, I'm not write all of it. So 1/5 is 0.2, 0.4, 0.6, 0.8. 1 over 4, 1/4 is 25 cents, right? 2 quarters is 50 cents, so 0.5. This is 0.75. Half is 0.5 again. 1.10, 1 over 10 is 10 cents, or just 0.1. 2 over 10 is 0.2, 0.3, 0.4, and so forth and so forth. All right, so these are at least the fractions that you should know by heart. So when I see 4/5, when I see this expression over here, my immediate thought is, ugh, I don't want to change the decimals to fractions. I want to change the fractions to decimals, because that's going to make my life a little easier. So negative 4/5, to me, that looks like this. So plus 0.6 minus, and a half is 0.5 plus 0.95. Much, much easier, to me at least, to deal with this. So now I'm going to take this bit by bit. 0.8 plus 0.6, who wins? The 0.8. And that's going to give me 0.2, but negative. So now I'm going to do this too, minus 0.5. So I want to change this to an addition problem. Oops, so subtraction becomes addition, and that becomes negative 0.5. Well, they're both negatives. Negative 2 plus negative 5 is going to be negative 7. Negative. And then I'm going to finally do that with 0.95 plus 0.95. Who wins? Well, there's more positives this time around. And if you subtract, right, put a 0 there as a placeholder, you're going to get 0.25. So the final answer is going to be 0.25. So much easier, I think. it's possible. So likewise here, already 9 over 10, I know I can change it. 2 over 5, I know I can change it. So I'm going to rewrite this problem as 2.2 minus 0.9 plus, inside the parentheses, negative 1.4, because 2/5 is 1/4. 2/4. Sorry, 2/5 is 0.4 minus 0.7. Look how much simpler this is. So let's start these two first. I have $2.20 and I spend 0.9. I am going to have $1.30 left. Now I'm going to add that to negative 1.4. Well, now the not friends here anymore. Who's going to win? This guy is going to win because he has 0.10 more, 0.1 more. And then I'm going to subtract with 0.7. Keep the first one, change subtraction to addition, and change that to negative 0.7. They're both the same, right? They're friends. So it's going to be 0.8. Pero negative. Okay, so again, same thing, but this one now, 7 over 15s, I know how to change that to a decimal. Okay, so I would probably leave that and change the 45 to a decimal, to a fraction. 7 over 15 divided by, and then let's think about what 0.45 is. If that says 45 cents, and cents is over 100, right? Or if you look at the decimal place value, the 4 is in the tens, the 5 is in the hundreds, so this is going to be something over 100. In this case, 45 over 100. And you can write it like that. Change it to a multiplication. And just multiply. Can I simplify anything? I can. The 100 was 45 or the 100 was 15. It doesn't matter. They're both divisible by 5, so let's stick with the 145. 45 divided by 5 is 9. 100 divided by 5 is 20. I can do 15 and 20, divide both by 5 again. 15 divided by 5 is 3, and 20 divided by 5 is 4. So if I clean that up, it's going to look like this. That's what I have left over. Nothing else can be simplified, so my final answer is 7 times 4, which is 28, and 3 times 9, which is 27. Final answer. Same thing here. Change one of them to your advantage, and in this case, change it to a fraction. 6 over 25 times 100 over 85. I can simplify 25 and 100. 25 divided by 25 is 1, 100 by 25 is 4. That's it, nothing else can be simplified. So 6 times 4 is 25, and 1 times 85 is 85. Final answer. Okay, not too many left over. Again, so this says let's find the sum of these two first and then divide. So let's do that. Inside here, let's change it to a mixed number. So I'm going to get 5 times 3 is 15 plus 4, 19 over 5 plus 2 times 1 is 2 plus 1 is 3 over 2. So let's focus on that right now and not the rest. So LCM is 10. If this was a times 2, so therefore times 2 over here is going to give me 38. Times 5 over here, so times 5 is going to give me 15. If I add this, it's going to give me 53 over 10. Okay, so this whole thing, I can go like this and go 53 over 10. So let me rewrite the expression. So I have 53 over 10 divided by, and negative 1.2, well, so it's negative. Let's talk about what 1.2 looks like as a fraction. So 1.2, well, where's the 2? The 2 is in the tens place, right? This 2 is in the tens place, so we got to put a 10 at the bottom. What do we write on top? 12. So it's 12 over 10. So now we're ready to change this to multiplication. Times, and the reciprocal is 10 over 12, and this is going to work out nicely because these two become 1, and finally we get 53 over 12. Likewise, same thing, so let's add these two numbers inside the parentheses. 2 times 3 is 6 plus 1, so this becomes 7 over 3, negative, sorry, plus 11 over 12. So let's take care of that and forget about the rest. LCM is 12. How did the 3 become a 12? It was times 4. So therefore times 4 over here. And 7 times 4 is 28. Pero negative. Now, we're adding, right? So the denominator is going to be 12. And now ask yourself, negative 28 plus 11. Who wins? The negatives, right? How many more do they have? 17 more, but negative. So this whole thing here becomes negative 17 over 12. Let's take that to the side. Negative 17 over 12. And we're going to divide that by 2.3. 2.3 as a fraction is something over 10 because the 3 is in the tens place, so it's going to be 23. So I'll divide that by 23 over 10. 17 over 12 negative times 10 over 23. Make your life easier. Divide this by 2. This gives you 5. Divide this by 2 gives you 6. A negative times a positive, so it's going to be a negative answer. 17 times 5 is 85. And 6 times 23 is going to be 18 goes 138. Final answer is this. Okay. So this one, let's move that down. Okay. Again, I would, in this case, change this to a decimal. So negative 0.88 is already a decimal. Plus, and 3 over and 9/10 is the same. So 9/10 is the same thing as 0.9, right? So if I add 0.9 plus the whole number 3 over there, that's going to give me 3.9, right? 3 plus 0.9, let's line up the decimals, and it gets me 3.9. So that's the same thing as 3.9. It's a negative plus a positive. The answer is going to be what? There's more of these guys, right? So it's going to be a positive answer. And how many more? Well, let's subtract. 3.9 minus 0.88. Add a 0 here. Let's borrow. 10 minus 8 is 2. 8 minus 8 is 0. And 3 minus 0 is 3. Negative 3.02. Over here, negative 1.45. And again, I'm going to change this to a fraction. And the 20s, it's almost the same. So let me show you how that works here. So let me change the 3 for 20 to something over 100. And that would be, so how did the 20 becomes 100? Times 5. And the top would be times 5, right? So 3 would be 15. So negative 2 and 320 is the same thing as 2 and 15 over 100. Which now that makes it much easier to change to a decimal. It's 2.15, right? 15 over 100. If I had $2 and 15 over 100, that means I have $2.15. Negative 1.45 plus, let's change that, negative 2.15. They're both negative, so my answer is going to be a negative, right? Because they're friends. And just add them, and that's going to give me 3.60. That's my final answer. Bottom, last one. Again, I would change, again, because I'm looking at my fractions, and there are fractions that I can change to easy decimals. So 0.54 plus 0.6 minus negative 0.75, because that's what 3/4 is, and plus 0.8. Talk about these two first. They're both what do you call positive, so it's just simple adding. 0.54 plus 0.6 is 1.14. I'm going to subtract this fellow here. 1.14 plus opposite of 0.75 is 0.75. If I add, they're both positive, so I'm going to get 1.89, which I'm going to finally add to 0.8. Again, they're both positives, so it's 1.89 plus 0.8. 916 goes 1, 269. So that's my final answer. Okay, so that should have been relatively not that difficult. Okay, just gotta be careful with your steps. That's it.